السلام عليكم ورحمة الله تعالى وبركاته. We will study today the curcumin compound. Curcumin is a multifunctional activity and he is very important compounds to treat many diseases. The curcumin belong to the diaryl heptanoids. This kind of compound we call it curcuminoids. So the curcumin, as we can see from the screen, uh, uh, consists of اللي هو two benzene ring. We have two hydroxyl groups and two methoxy groups. And what these are the main characteristic of this compound is has a tautomerism. عنده صفة التوتمرية بمعنى أنه this compound can be found in enol keto form. الإينول البرسنتج 90 to 95%. الكيتو from 5 to 10%. So this is phenomena of the curcumin has a tautomerism, a tautomeria. Okay. If you look at first at the UV, the UV spectrum is strongly pH dependent. So as you can see, different solvent, if you use ethanol or you use sodium hydroxide, pH 13 or acetic acid, so you will see that it gives you different absorption. But the absorption of the band at 430 nanometer. Well, this is indication that this compound has conjugation systems, and this compound in conjugated systems. Okay, so they mentioned that experience a bathochromic shift. كلمة bathochromic shift is also known as red shift, referred to the movement of the absorption maximum lambda maximum of a molecule to larger wavelength. لما نقول larger wavelength معناها lower energy in UV visible or fluorescence spectrum، يعني الانزياح نحو الأطوال الموجية الأطول فبيدينا أقصى امتصاص لللامدا ماكسيمم لمركب كيميائي نحو طول موجي أطول، بمعنى أنه نحو طاقة أقل في اللي هي طيف الامتصاص، مثل طيف الأشعة فوق البنفسجية المرئية أو في طيف الفلورة. العكس تماما له حاجة يسمى هايسوكروميك اللي هي انزياحنا على طول موجي أقصر، وفي الحالة دي بنسميه البلو شيفت. أوكي، نسميه البلو شيفت. So the pH are if but these solutions at high pH are unstable, must be measured directly. Okay, this is the compound, and this is the IR. Well, IR obviously the OH stretching band for phenolic compound in the double bond region. One would expect a carbon double bond oxygen and the aromatic carbon double bond vibration. Two narrow bands are seen at 1630 centimeter minus 1 and at 1630 centimeter minus 1 and at 1600 centimeter minus 1 comparison with اللي هو acetyl acetone shows two similar band at this frequency. ما هو الكومباوند هنا بيحتوي على hydroxy group. Very obvious clearly. طيب this is color of the compound and it's very famous in Asian countries. This is the numbering system. In some other reference, they have a different numbering system, but here we will stick to this numbering of this book, and you can see very clearly that We have 1, 2, 3, 4. This one heptanoid and two benzene ring. So from this compound, we expect that we have 11 signals of carbon 13 because it has symmetrical. So here, 1 prime, 1 prime, 2 prime, 2 prime, 3 prime, 3 prime, and then the mesoxy, very clearly, the mesoxy 7 prime, 7 prime. Okay. From the proton NMR, it is clear that we have aromatic ring. Usually, aromatic ring in general between 7 to 9. This is the aromatic region. And sometimes, if it is shielded or deshielded, so the value may be lesser. But in general, it is from 7 to 9 ppm. Okay. Here we can see the protons of اللي هو 4 و2 و5 prime, 6 prime, 2 prime, and 1. 1 and 2, this one, it is not from aromatic ring. The aromatic ring is 6 prime, 5 prime, 5 prime, and 2 prime. This is from aromatic ring. 1 and 2, this one, it is in trans. It is olefinic in the trans form. And this is we can know from the J value. If the J value it is 16 or 15.8, this one it is they are two protons are in the trans form. It is if it is between 6 to 12 indicated that it is cis form. Okay. So from the proton NMR, the proton NMR shows in the aromatic region an AX spin system. So what is AX spin system? This means A and X are two non-equivalent protons, and they are scalar coupled to each other. They split each other cell the signals. So here we have two values, 7.53 and 6.74 ppm within a spin coupling of 15.8 hertz, indication that it is transformed, trans. So which can easily be assigned to be the proton 1 and proton 2 of the trans olefinic bond. So the AX spin system embarrasses the aromatic protons اللي هو 2 prime, 5 prime, and 6 prime of the 1, 3, 4 tri-substituted aromatic ring systems. زي ما هو واضح as we are also seen in the spectrum اللي هو زي ما شفناه في اليوجينول. These protons display a very typical patterns, and their individual assignment is obvious due to the small spin coupling between 2 prime and 6 prime. This is 2 prime and 6 prime. So this is meta coupling. This is called meta coupling between a 2 prime and 6 prime. Okay. So the singlet at 6.05 ppm integrating for only one proton. This is the integration as we see. The methoxy 6 approximately 6 protons, and then we can see the 5 prime. It is 0.94. It is approximately 1. This one will tell you this is the numbers between اللي هو بين الرقم ده. It is the integration. Will tell you how many protons are there. Okay. So the singlet at 6.05 ppm integrating for only one protons is assigned to proton 4 and confirms the symmetric structure, because the symmetric structure is drawn in enolic form. enolic form this is enolic form. لو كانوا الاثنين ديل كيتون بنسميه داي كيتون، وده very very small quantity will be in داي كيتون 5 to 10%. So the assignment for the methoxy proton signal at the layer, as we see previously, at the layer 3.82 ppm is obvious. So the enolic hydroxy protons is in exchange with phenolic hydroxy protons and residual water of the solvent. Here, not shown. Yeah, this is the compound, and we come to the cozy. Here, it is very clear. I know you have very nicely cozy between 1 and 2, and should be between 5 prime and 6 prime. This is very clear for the cozy, because we have symmetrical, so that it will appear at 4 cross peaks. Also between very nicely correlation between proton 1 and proton 2, and also the other correlation between 6 prime and 5 prime, proton 5 prime and 6 prime. This is vicinal protons. So the cozy the spin coupling described are nicely revealed also in the cozy spectrum to display the cross peaks for the small spin coupling between al 2 prime and 6 prime would cause an overflow for the other signals. However, these peaks can be easily observed on the computer screen and enhanced by using long range coupling. ممكن نستعمل توكسي برضو لو كان في 3 protons اللي هو 1 3. But here very clearly we can determine or observe the cozy correlations, proton-proton correlations. We come to the noisy spectrum. Unfortunately, the off diagonal peaks are not in the red colors, and but it is very clearly the correlations. We can see the correlations between 2 prime and 7 prime. Very clear. And also between 2 and 4, 2 and 4. This is a noisy proton-proton correlation, and this is we will tell you about the stereochemical analysis of the compound. So in the noisy spectrum, all signal have the same sign as a diagonal. Therefore, they are printed here with the same color. Usually the off-diagonal peaks will be on the red color, But in this book, they print it in the same color. So for the molecule of this size, this is unusual, even in the MSO solution. And explanation for this in the ongoing keto enol equilibrium, where normal NMR detects only the predominant enol form, but noisy is able to detect the exchange of the sign of the cross peaks. As I mentioned, noisy spectrum confirms that the methoxy is located in the vicinity of the two prime, two prime, two prime, and also shows a strong NE between 4 and 2, 4 and 2, 4 and 2. The significance cross peaks between trans olefinic 1 and 2 also. 1 and 2. 1 and 2, yes. 1 and 2, yes. And the cross peak of 4 and 1. 4 and 1, yes, very clear. The correlations are probably induced by keto enol equilibrium. This is the carbon 13 spectrum, and it is very obviously lower the In carbon 13, the two obviously assignable signal are from the carbonyl formula carbon 3 at 183 ppm, and the methoxy clearly methoxy group اللي هو carbon 7 prime at 55.7 ppm. Note that the chemical shift value of carbon 3 is also indicative for the enolic form, and the other carbon H signals will easily assign via the HSQC spectrum, since the proton's assignment is already complete. The remaining three quaternary carbons will be assigned with the help of the HMBC with the HMBC. هنا الكواترنال واضح هم أو عندك الكربونايل 3 وعندك ال 4 برايم وال 3 برايم وال 1 برايم، بينما السي اتش اللي هم ال 1 والكربون 6 برايم و 2 و 5 برايم و 2 برايم and 4. عندنا الميثوكسي اللي هي عبارة عن 7 برايم. Okay, so from the other CH signals will easily assign via the HSQC spectrum. ال HSQC هو اللي بيوضح لك الياتو بروتون مرتبط بياتو كربون. Okay. عندنا as the total number of the signals indicate the symmetrical structure. عندنا 11 signals. Okay, so we go to the HSQC. هنا very clearly هنا ده ال 7 برايم correlate اللي هو البروتون 7 برايم مع الكربون 7 برايم. عندنا الأربعة تنازل تحت اللي وتمشي على اليمين، الأربعة البروتون 4 مع الكربون 4، البروتون 2 مع الكربون 2، بروتون 5 برايم مع كربون 5 برايم، البروتون 6 برايم مع الكربون 6 برايم، 2 برايم مع اللي هي 2 برايم، وال1 بروتون 1 اللي هم مع كربون 1 اللي هو ده الكوريليشن اس كيو اس كيو سي. الكويتين ما بتصل والكربونايد سي 3 ما بتصل، فقط اللي بيكونوا شنو يحملوا البروتونات. وهنا ده عبارة عن 7. طيب as the HSQC spectrum reveals the most shielded olefinic carbon signals stems from the اللي هو carbon 4. This is the most likely also caused by keto-enol equilibrium, by which this carbon exchange with the methylene group signal. So the signals of the carbon atoms, low carbon 1 and carbon 2, have the usual order found in alpha, beta, and saturated ketones. هنا ال HMBC expansion of HMBC، وهنا بيوضح لك الكوريليشنز بين البروتون والكربون. هنا هيتيرو وعشان ما تعرف الكونكتيفيتي. هنا هتنزل تحت اللي هم ال7 برايم، هتشوف النيوكليوس قصاد شنو هنا ال3 برايم. ال3 برايم هنا الأربعة كوريليت، هتشوفها اللي هو البروتون 4 هيكون كوريليت انت تنزلها تحت to the 3، وعندك 2 to the 3، وعندك 1 to the 3 التي correlations. فانت you do all of the correlations عشان ما تعرف الكونكتيفيتي. you do in the table اللي هو كل بروتون correlate to الكربونز you write down. So the HMB6 spectrum clarifies the assignment of the quaternary carbon signals اللي هو carbon 3 prime at 148 ppm. It's seen from the methoxy protons and from the 5 prime, whereas proton 2 prime and 6 prime have اللي هو هنا J3. هنا J3 carbon H. احنا ما قلنا في ال HMBC لحد J3 spin coupling to the carbon 4 prime at 149.4 part ppm. Carbon 1 prime at 126 0.4 ppm displays the two expected connectivities اللي هو to hydrogen 5 prime and hydrogen 2, although no longer needed in this case. for carbon 3 is seen by اللي هم البروتون 1 وبروتون 2 وبروتون 4 very clearly، اللي هي 1 و2 و4 بيشوفوا منه الكربون 3. ده الموليكولار ميثود of the curcumin. And then we come to the MS. ال MS هنا واضح انه الموليكولار ايون بيك 368، وهنا البيز بيك اللي هو 100% intensity اللي هو 177، وده بيوضح لك اللي هم الفراجمنتيشنز. وده دايما ده suggested by بروف اللي هي كيبي زيلر ل University of تمبنجين. التبنجين دي اللي هي دي جامعة موجودة وين؟ في جيرماني، في جيرماني ألمانيا. نجي هنا ده للتيبل. التيبلز اللي هو اللي بيوضح لك، التيبل هنا بيوضح لك الكربون 13 signals of BBM in BBM، والتايبس of carbon وassignment، والبروتون signals اللي هو BBM، وبديك الجي in هيرس. هنا واضح انه هنا الكواترنري أربعة اللي هم الثري والفور برايم والثري برايم والون برايم. الثري والفور برايم والثري برايم والون برايم. هنا ملاحظين انه في السي اتش اللي كربون 1 اللي هو الاتش، والكربون 2 الجي coupling same 15.8 indication is a transform اللي هو البروتون بروتون الاثنين في الحالة بتاع الترانس، وعندهم different اللي هو chemical shift. واضح انه السي اتش هم اللي هم واحد 7 1 2 3 4 5 6 اللي هو 1 و6 برايم و2 و5 برايم و2 برايم و4 اللي هم كم؟ 1 2 3 4 5 6 اللي هو بروتونز. وعندك الميثوكسي اللي هو عبارة عن اللي هو C7 ل 55.5 الكربون 13، بينما البروتون اللي هو 3.81. اوكي. عندك الكربون 3 اللي هو 183.2. This is the carbonyl. This is the questions. You try to answer these questions. And thank you very much for listening. والسلام عليكم ورحمة الله تعالى وبركاته.